Hi there, I'm Chris Holzhauser, the Managing Director for Advanced Manufacturing at BlueForge Alliance. And I'm here with Jim O'Toole today of CAM. Jim will introduce himself and give a little overview of his organization.
Yeah, hey, Jim O'Toole, VP of Engineering and Sales at Keselowski Advanced Manufacturing, now a part of the ADMAN group. You know, our organization is an organization focused on additive manufacturing and the complementary post-processing, so 3D printing using laser powder bed fusion, all the way through the CNC machining and post-processing to deliver compliant hardware to our customers. So, as we're all aware, the additive industry continues to grow, and there's a lot of applications, especially in the industrial base, that we hope to leverage.
We at BlueForge have a connection to the other side with RFK racing, but CAM's a little bit different in that they are really into getting their hands dirty and contributing more to the tactical side, and that's how I know you all. I don't know necessarily the flash and show of NASCAR. Can you just give a distinction for us, just to, you know, where those lines are at? And
yeah,
the
sure.
difference?
So, you know, CAM was founded by Brad Keselowski, who's active Cup Series driver, part owner, active Championship Cup Series driver, and part owner at RFK Racing. Who, you know, they do a great job of representing the BuildSubmarines.com brand along with BlueForge Alliance in order to bring the awareness to the needs of workforce development. Just no different for CAM, where we need that workforce development as well, right? So what we gain from the partnership that RFK has with BlueForge Alliance is that they're continuing to generate that awareness for we need people. On the CAM side, you know, we make the distinction that Brad founded CAM in 2019 with an entirely different mission. So we're not associated with RFK. We don't do racing components. And what we are doing in terms of activation with BlueForge Alliance is the true, how do we actually make parts? You know, on the 25 plus additive machines that we have, along with the complementary CNCs, quality procedures, all those things, how do we actually make parts that are going to wind up to support the shipyards?
And now it's interesting how CAM got into additive manufacturing. You know, it's not something that you necessarily would associate with, you know, what Brad's kind of vision and those types of things. So what really was the deciding moment or the motivation to really drive to the manufacturing side?
Yes, I think Brad, you know, he obviously could tell the story better than I could, right? But I'll do the best I can. So Brad really comes from a manufacturing family, right? His grandfather was a machinist. His dad, his uncle, they built cars. They did a lot of things in the Michigan area like that. And Brad's always really had a passion for manufacturing. And what really sparked his interest specifically in additive was there were some race teams that were actually using metal additive, and even the team that he was previously with had dabbled with additive manufacturing in order to achieve a higher level of performance on track. Brad, at that point, kind of got bit by the bug, and he had almost insinuated for the race team to maybe invest in that technology to move it forward. And really, when those challenges weren't met, Brad decided that I think he took a trip to Germany, visited a few of the different additive machine manufacturers, and he really got bit by that bug of saying, this is something that we need to bring so that we can onshore, you know, manufacturing that is now taking place in other countries and things like that. And he really feels that this is the way of the future for how we create some of these components. So I think initially when he started CAM, he thought that there would be motorsports applications, and he thought that there would be a lot of interest around building parts for the race team he was currently with, and maybe even potentially other race teams. But once the first machine was on the floor and he started printing parts, he started getting interest from a lot of different industries: aerospace, commercial space, traditional defense, and he realized that the ability for additive to kind of influence the next industrial revolution spanned well beyond anything in the racing environment. And kind of at that point in time, he had an inflection point where he said, we need to build CAM as a leader in the industry for high fidelity, high quality components that can meet the rigors of FAA requirements, Department of Defense requirements, and really that's been our drive since day one. If you look at how we've made strategic moves to become AS9100 certified, become NADCAP certified specifically for additive, multiple customer qualifications and certifications, from our core and from our DNA, we are built off of being process driven to deliver those high complex, high fidelity components. And of course, that fits really well within the aerospace and defense environments.
I'm glad you mentioned the kind of process driven and the quality that CAM is known for, and that's definitely needed from a submarine perspective and what the Navy is looking for. How has that helped you get through some of those certifications, specifically what the Navy is asking of you, which can be pretty imposing?
Yeah, I think one of the interesting facts about let's use the Navy, the NAVCO5 technical publication for additive manufacturing, right? It's so much more than can you print parts. It's how do you control the contractual obligations from the time the contract is accepted until the time that you deliver the parts, and probably more importantly, the stack of paperwork that goes along with the parts to make sure that they meet the rigors to keep our men and women safe, in the armed forces. So I think because culturally we are built around processes and we are built around performing to those rigors, it was not a difficult task for us to flex to meet the standards of what the Navy was looking for. So step number one, get our hands on the tech pub and make a very exciting read, right? So you're reading, you're trying to understand, you're interpreting the requirements. The Navy team was great, right, providing input. We also had some support from some external folks who had kind of pioneered the process at the AMCOE, right? So as the AMCOE, they went through this same qualification process, and they kind of developed a playbook that said this is the best way to take this on. So what we were able to do is, part of that process is developing a quality assurance plan and a process control plan. And that really has nothing to do with how are you printing parts. That is all the other things. And for CAM, we were able to leverage our pre-existing processes for things like powder handling and machine qualification and all these types of things, and really just reference those within our quality assurance plan and our process control plan. So the package that went to the Navy team for approval really just references our standard QMS documents and say, this is how we operate on a day in and day out basis. And I think that if you were to be a greenfield startup of an AM facility, or be a machine shop who decided one day you wanted to invest in AM in equipment, which is great. We need more entrants into the market in order to be able to make sure that the additive supply chain is viable. But if you had to read that document and build out all of those processes specifically to become qualified, it would be a relatively lengthy process, right? The shortest part of that is hitting the print button and making some coupons. So really, I think that high level of prowess in process control and our quality-focused, customer-driven mentality is what helped us achieve that qualification in a pretty short timeline.
Yeah. So in your additive journey, you talked about these other industries supporting defense. Navy has taken a really unique approach and a very aggressive approach on really pushing through certifications for additive, and the existence of BlueForge is to help kind of facilitate that. What's your experience has been on the technical side with BlueForge supporting you, extension of the AMCOE, those types of things? So what can you share specifically to that?
We see a lot of different documents from a lot of different customers, right? And everybody wants things done a little bit differently. And almost all of those documents, outside of if you were to look at a technical drawing that said, here's the dimension, plus or minus 10 thousandths, there's not much interpretation to happen there, right? It's you're either in or you're out. When you have some of these documents that are lengthy, having an extra set of resources with the AMCOE and with the folks from BlueForge Alliance to be able to garner some technical background knowledge to say, hey, we've had someone do this before, so we know it reads like that, but this is really the interpretation that the Navy is looking for. So having that ability to rely on technical resources is certainly key. Also, having someone like BlueForge who is tied in with and driving the mission with the Navy is really critical, because as you can imagine, the architecture of an organization like the Navy is pretty vast, right? There's a lot of different communication streams, but at the end of the day, we're all trying to meet the goal of 1 + 2 + AUKUS plus sustainment, right? So having a good understanding of who our point of contact is to get those answers is much better than us having to create an email chain with 50 people who are within the Navy, and hopefully someone brings us the answer that we're looking for. Right. And CAM, we're an organization of about 43, 44 people. So anytime that we can leverage these type of partnerships where we can utilize your resources to help us do that, it allows us to continue to focus on what we do, which is build top quality components with those riggers, right? And we don't want to have a person who their entire role and responsibility is to go interpret and understand and communicate and all those types of things, because at the end of the day, that's not our business, right? So having those resources kind of far and wide was very helpful as we work through this.
Yeah, that's awesome. It's so good to hear. Glad that the team is supporting you. In your time with CAM, your history with them, what is one of maybe your proudest moments or some success that you've witnessed in delivering these parts that are so vital to us?
Holistically, we've experienced a tremendous amount of success based off of that process-driven mindset, right? We've had multiple programs outside of the Navy work that we're working on that we have seen go from an idea of our customer now being in low-rate initial production at 500 to 1,000 units per year, right? And 6 years ago when CAM was started, 3.5 years ago when I joined CAM, we didn't really have a lot of that, right? The additive journey was really just starting for everyone. Of course, additive has been around considerably longer than that, but the adoption curve has really accelerated. But if we focus specifically on the Navy side of things, our ability to go from interpretation of a technical publication to having a machine and process for stainless steel 316 fully qualified to the NAVCO5 technical publication in 6 months was a huge success for us, right? And I think that multiple site audits, right? You had site audits from NAVSUP, NAVAIR, NAVC, right? And probably the proudest thing that I can say for our team is all of them left completely satisfied with the processes and procedures that we had built, right? I mean, I think one of the comments was, CAM has now set the bar for what the expectations are for the way that you control processes, right? And the team at CAM is the one who did that, right? Like, this is not one person who's writing these processes. This is collaboration up front, followed by continuous lessons learned in order to understand best practices that we build into our processes. So I think when I talk about the biggest success is the way that our team of folks work together to meet varying customer requirements on a day in, day out basis, and do so with grace and integrity. And I never have to question whether or not the components that we're delivering to customers meet their requirements, because we understand the rigors that we need to go through, and we have the onus that if we're not meeting those requirements, we're going to be transparent with the customer to make sure that they understand the limitations that we have. So,
yeah, it's incredible. I 100% agree to the quality piece, and that bar being set extremely high, and I think that's what we're going to expect going forward. So appreciate you all being somewhat of a pioneer to that. From my angle, as trying to be a good partner of you, what else can we be doing, and by extension, what else can the Navy be doing to really help you take that next step?
There's a lot of things discussed about the need for additive manufacturing to really specifically focus on the replenishment of castings and forgings that have tremendously long lead times, right? And there's discussion around of the total volumes of materials that need to be produced over the next 5 to 10 years to fill all of the gaps within the bill of materials on the Virginia class, the Columbia class, even the Ohio class, right? Trying to understand how do we keep all these, and then expand beyond the submarine industrial base and talk about, CVN aircraft carriers and anything that's entering dry dock for any type of maintenance requirement, right? There's the opportunity that additive can get that boat back in the water, protecting our nation faster. So I think that it's known that can be the case. I think what we're still struggling with is how we turn that into a reality. And all of these projections around how much we're going to need and all these types of things, those are great projections, but they don't have dates, they don't have part numbers, they don't have when do we actually need to execute on this. And from someone like CAM, contract manufacturer, having 25 plus machines, these machines are very capitally intensive. And our payback is based on those machines making parts day in, day out. So we don't have the liberty to say, hey, let's take this $1+ million machine, set it in the corner, have it qualified to copper nickel 70/30, and when the demand comes, we can start printing parts. Right? As we've worked through these qualification procedures, we've had to qualify the equipment, and then we've had to move on to other customer programs that likely are not within the same material set as what we had qualified, which I will say that the NAVCO5 Tech Pub gives you that ability to transition into another material set and then back as long as you can meet the chemical composition requirements and things. So they haven't handcuffed us there. Where some customers, once you qualify the machine, you cannot take it out of that material, or you have to go back through the entire qualification process. So that's helpful, but I think really what we're looking for is a purchase order, right? Yeah. We need to make parts. And even as we look at my hope that we continue to qualify more and more additive facilities to do this, because based on the volumetric demands that we need to produce, it's not going to be handled by one. And also, CAM, from a strategic standpoint, we have to stay diversified, right? So we cannot say, let's take all of our machines and produce Navy components with it. So as we look at those future entrants, we need to understand the duration of qualification, average qualification, and we need to tie that to what the legitimate demand signal is that parts will need to be made. So if we need to start producing parts in September, we need to back that off the 8 to 9 month period to do the full qualification and say that's when we start qualification. Because the situation that we're in right now is we're seeing some requests for proposals from some of the Navy partners, tier 1 shipbuilders. And the question is always, how fast can we get these parts? Well, from a fiscal responsibility standpoint, CAM, we need to be booking our machines out as far into the future as we possibly can. If I can fill gaps in the production schedule, if someone wants to give me a purchase order that keeps the machine busy for the next year, I'm not going to tell them no, because we might print something for the Navy, right? So that's a constraint that we see right now. Our capacity has been consumed in a big way through all of these other adoption curves of different industries. And now my fear is that we won't have the capability to support these efforts in the near term. So I think that additive itself is in an interesting perspective where the use of supplier development funding fits the bill to an extent. Supplier development funding, through my understanding, can be used for multiple different things, right? Some being pre-funding long lead time items, these types of things, but more importantly, being able to invest in the infrastructure to be able to support those needs. And on the additive front, if we want to have machines ready to do that, the only way to do that is to obtain some type of supplier development funding and have an installation base of dedicated equipment that will be ready when this needs to happen. And this isn't a long-term thing, right? This isn't, we expect that the Navy or the shipbuilders through supplier development funding need to support that effort for the next 10 years. Because as we go through this adoption curve, you're going to see technical data packages, TDPs created at the AMCOE at a very high rate, right? And those may be what is flowing across those machines. But then as we look out the next 3 to 5 years and folks like, Electric Boat and Huntington Ingalls are continuing to allow additive to replace components, their demand curves to operate those machines are going to go up. So really that equipment that is now idle will be filled with the work that needs to come from those facilities. So really, I think if we want to have a sustainable industrial base right now in the additive front, and this isn't just CAM, I think this spreads across the entire industry, no one is in a position where they can invest in equipment and for it to sit idle. A lot of us are in the position that we can procure the equipment through supplier development funding, have it qualified and ready, and then start producing those components once they become available. So I think that's one of the stripes for AM right now is the cost of equipment is high, the hourly operating cost is high. And I say high, let's compare it to casting, right? A casting house, you're investing in dies and molds and things like that, but you're not investing in the infrastructure to cast that component. On the AM side, we've invested in the infrastructure, which is the machine and all of that wonderful quality stuff we talked about, which is not cheap to maintain, right? So we need to find a way to bridge the gap to where we can have equipment ready for production. And really the only way I see that is two ways. One is POs right now to start manufacturing hardware, or supplier development funding in some manner to have idle equipment ready to execute on those POs when they become available.
Well, I think message heard loud and clear. It's been such a pleasure working with your team from a technical perspective. Appreciate your time and insights today, Jim. So it's really good.
Yeah. Thank you.
Getting to talk with you.
Yeah, you as well.
Thanks so much.
Appreciate it.